Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is New Era of Computing with IBM PureApplication System. Our guest speaker today is Mr. Amol Mahamuni, Program Director, IBM India Software Lab, and a Product Manager at for IBM PureApplication System. Mr. Amol has 25 years of industry experience and has been with IBM for the last 16 years. He has been with India Software Lab since its inception in 2001 and has played key leadership roles across products portfolio in growing the lab to its current level. In his current role, Amol is responsible for IBM Pure Application Systems product management and business development. IBM Pure Application System integrates all IT elements together in single system to address IT complexity, resiliency, deployment, and IT manageability. Earlier, Amol managed Software Group WebSphere brand application infrastructure portfolio, including Java Technology Center, mobile products, and WebSphere application server portfolio, which is key component for all of IBM SWG middleware. Within the application integration and middleware portfolio, his earlier job role included managing IBM Telecom product portfolio development, WebSphere commerce portfolio, platform technology center, and distributed CICS transaction processing. Mr. Mole began his career in research at DRDO and then ISRO for initial 6 years of his career, after a brief stint in academia as a faculty. Pursuing his interest in networking and system, he moved on to IBM US working on networking and device drivers before moving back to India for good in late 2000. Amol has a master's degree in electronics and communication from IIT BHU from 1989 batch. He is also an IBM certified project manager at IBM India. So without further delay, I introduce you all to our guest speaker. Over to you, Mr. Amol.
Hey, thanks, Mohini. Am I audible? Mohini, am I audible?
Yeah, you're audible.
Okay, terrific. Just wanted to ensure that I'm audible. Before I begin, first of all, thanks, Group, and thanks, Mohini, for the introduction, and thanks for the opportunity as well. So it's my privilege to introduce the IBM PureApplication System, one of the biggest innovations from the stability of IBM over the last couple of years, and we call it the launch of this decade. So before I begin, just again want to check if my slide is visible. Mohini, I'm on the first slide, and is that visible enough?
You can start now. Your slide is totally visible.
Okay, terrific. So thanks again, Mohini. So to give a very brief introduction before I give on a slide, before I even go on a slide deck. First of all, thank you for attending this. Again, it's my privilege to talk about this, one of the latest and greatest innovations, fresh out of the oven, from the entire software group, systems group, and services portfolio of IBM worldwide. So we started looking at what are the bigger pain points in the industry, what is it that we really want to do differently, what innovation do we want to bring in from the products perspective, from the services perspective, to look at how the IT can embrace innovation much quicker and faster, which will carve out a business niche for them. I mean, that's the vicious competition that we have today. And for the IT businesses to be successful, we surely have to look at what's the differentiating factor, may it be adopting in mobility or analytics or, any of the different technology innovation that you need to put with faster time to market, and without needing to bother about the foundation on which you're building your application. So to begin with, on the slide 2, if you look at the reality of getting your IT up and running, it takes at least about a quarter to integrate different pieces, to procure, to make the decisions on the middleware, to write your application, to stitch and cobble the whole solution together. But that's not all. Your ongoing efforts to troubleshoot your solution, to fine-tune your solution, to have the processability which is quite often required into business processes. It's an ongoing vicious cycle. Take an instance, if you have a security upgrade or a security patch that need to put in a solution, or if there is a version upgrade on what are the software stack that you're using, that takes at least about a quarter. So that is the hindrance when you really look at the business goals. You want to drive a business with the innovation and the speed at which you can go to the market with the new innovation. You need to be able to respond to the threats and opportunities in the market and kind of respond to the dynamicity that you have in the market. The dynamicity could be if you have a system and if it's not scalable enough for you to meet a Christmas demand or a Diwali demand, or if there is a disaster management system, or if there is a natural calamity, which is something like tsunami, for instance, how are you going to be able to respond to those threats and opportunities? So what we see in one of the IT surveys is little over 30% of the IT projects are deployed late, and over 50% actually experience a downtime when there is any kind of an infrastructure or middleware upgrade, even after the well-oiled system has been deployed. So moving on to the next slide, there is another very interesting research which we've gotten into. Before we even embarked on the journey of creating this pure systems or expert integrated systems, what we find is just about 20% of the clients, and these clients come from different business verticals, may be from healthcare, government, retail, telcos, BFSI, banking and financial, whatever it is, right? Now, if you really look at what is all of these people doing, all of these data centers doing, all of these ITs are doing, right? About 20% of them are able to have half of their IT budget spent on innovation, which means the other way, probably about 80% of our businesses today worldwide, India inclusive, is not able to put even half of their focus on innovation. And the reason is, if you see on either the left or the right, let's just focus on the right over here. Even the most efficient data centers, even the most efficient, the best of the breed data center are putting 47% of their effort, which is money and effort and obviously blue and green dollars together, in just keeping the lights on. And just about 50% is what they can allocate to the new projects, which is embracing innovation and trying to carve out a business niche for you to be more successful in the business, right? I mean, unless you change, you see in many of the telecom companies, many of the, not just the providers, 4 years back, there was a completely different mobile company which was ruling the roost. Today, it is a completely different company, and you know there are names which are ousted and wiped off the face of this mother earth, right? Even in the retail business, for instance, talk about something like Kmart or service merchandise or what have you, and there are different businesses which are in the same line of business like Walmart, which makes over $400 billion revenue per year and be very successful. So that's the differential that we're really talking about. Now, if we move to the next slide to look at what are the different approaches that all of the clients have been doing in order to address this opportunity or the threat in the market. And they are completely two sides of the spectrum. On one side of the spectrum, we call it as a client team system. And the client team system is the one which you make your own procurement decision. You make your own decisions on what middleware and what foundation you want to host the solution on. And you try to stitch this entire solution together, which is more like a hand wiring and stitching this whole solution together. And then you put an application on top of it, and then you maintain it, then you tune it, then you optimize it, then you stage it, then you test it, all of that together, right? Of course, it's a great thing because you have all the knobs to tune. You know, the best part of the client tune system is you got 100 knobs to tune. And the worst part of the client tune system is it has 100 knobs to tune. So take an instance, if I draw a parallel to an automobile, for instance. Your automobile today which you drive is pretty similar or rather much better in capacity than the mission which was man on the moon mission, which was 1969. Now imagine the complexity which must have been there in the real-time trajectory controls. And that kind of a computation is there in the cell phone today, even in an automobile. And when you talk of that kind of a control and complexity and the processing power in your automobile, if you get similar kind of the knobs to tune, which is, well, here is what you're going to do for deploying your airbags or activating your anti-lock braking system or what have you, probably 99% people will create more accidents rather than it being a safety device, right? So there is, if you, without going more detail, just take the foundation, for instance, right? Take an app server, take an UDP layer. you get about 25 switches at JDK, whether it is IBM or Oracle Sun or whatever it is, right? There are too many of those which again comes in permutations and combinations which you need to tune yourself, which is true for most of the IT solutions today. The other end of the spectrum, which probably is better off, which is in appliances. And that's a completely different end of the spectrum. The reason I say this is, in an appliances-based model, it is simple plug-and-play kind of form factor. It is easier to deploy, it's easier to maintain. But all these great things, unfortunately, are single-purpose built. Your cell phone, in a way, is an appliance. Most of the telephones that you use today, or an iPad, is an appliance in a way, right? Appliance because you actually don't open and in an iPad you don't do anything, right? You don't change your memory, you don't change your battery, you can't change anything. It's something which is a sealed unit, which is an integrated system by itself, and that is kind of an analogy of an appliance. And a lot can be talked about cloud. I won't take much time to talk about cloud, but the fact is, when you talk about cloud, the elasticity of a cloud, the security in a cloud, the kind of a cloud bursting capacity that you need to have for your hosting of your middleware solutions, hosting of your enterprise solutions, and the shared dependence which you have from a service level agreement perspective. You're certainly going to bank on the infrastructure capability of your service provider to be able to cater to your service level agreement which you are signing to end customer. If you're a banking portal, internet banking portal, if you're a retail customer, if you're a retail portal, retail provider, for instance, you are trying to get an SLA to your end consumer that your portal will have 2-second or 5-second response time per click. What if your retail portal is taking 15 seconds? No consumer is going to stay on your portal and they'll make their buying decisions from your competition, right? So that's the era that we're really talking, where there is a vicious competition, and there is no one solution, unfortunately, what you see in this chart is fitting into all of these needs. One which gives you that agility, which gives that flexibility, which gives you that control, one which gives you that easier plug-and-play form factor, and one which can truly have that private cloud environment and that kind of a cloud bursting with all the security, scalability, quality, service level agreements, of course, the maintainability and deployability as well. So what if we can get a blend of all these three? And that's where IBM have been started thinking about. And we started thinking about it about 2.5 years, 3 years back. And we actually called it a project team select. So when we got started from IBM Research, and as you know, IBM Research is across the 8 countries, we spend more than $5 billion per year. But on this project alone, we spent over $2 billion with 17 labs coming together across the geographies, India inclusive. And I was happy to be part of this project right since inception. And what we really designed is, and what we evangelize today, is what's called an expert integrated system. Now, the reason I dwelled on the word expert is, I'm going to define why the expert is extremely important over here, and why integration is also important over here, and what is going to be this family of products called expert integrated system. And when you talk of a family of products, it's not just one single product that we're launching. The PureApplication System, or rather the PureSystems that I'm going to talk today, is certainly the first launch in the export integrated system. But as we really go into the next quarter and maybe next year, you will see more and more such products coming into this line. And the whole theme, the whole evangelism, the whole thought process around this is trying to take care of most of the obvious things in creating your solutions, in managing and maintaining your solutions, and maintaining a data center in the best and efficient way and scalable and monitored way, which allows you to put most of your focus onto the business innovation that you're going to bring in. And that's exactly the world is moving towards, and which is what we started thinking about. And we are certainly the first one to think about launching a system which is an integrated system of this kind. And it comes with these 3 basic tenets, which is built-in expertise, integration by design, and simplified experience. Allow me to dwell on each one of these for a minute. So built-in expertise. This is extremely important. I'll give an example of, I gave an example of an automobile. So go back again to the same example. If your car was not having that built-in expertise which comes right from factory tuned and optimized at whether it's Toyota, Honda, or whichever car you drive, or even Tata's for that matter, you're not going to be able to optimally tune it all by yourself. A, because it's something which is somebody else's hardware. somebody else's middleware, software, processing power, whatever it is, right? Storage, networking, all of the moving components which come in a car. Let's call it, in the automobile example, you may have the best of the breed gearbox and best of the breed, engine and what have you, right? The struts and safety devices. But if you don't know how to optimize that solution, which is that built-in expertise that the systems come with, quite possibly even a mistune it, right? If the tuning is left to you. So that has to be tuned in from the factory by, we call it 80-20 kind of a rule, right? The typical 80-20 rule is 80% of the things can be optimized at the factory level itself, and then leave this 20% controls to you. So the built-in expertise in IT industry, if I give an example, there was a client, and I won't be able to name the client, who took almost about 3 months in deploying our waste performance solution. After the deployment, they came back and told us something is probably wrong because the retail business port was taking 15 seconds. We went back and did dynamic caching, and within a day, boom, it just started working with 2 seconds and 2.5 seconds, right? So that was great. Now, what is the trouble, right? It's not that we, as the product vendors, didn't want to go and tell this retail business vendor that you need to do something like the dynamic caching. Of course, they have manuals out there and people can read it, but you need an expert who can look at the deployability of the environment and can tune it. What if we self-tune this system, right? Again, the same client came back and told us the search engine optimization is not optimal, because when they actually when any client tries to look for a retail product, it doesn't come in the top 50 or top 20. Now, there are ways in which you can shorten the URL, you can do the SEOs. It's just that the client didn't know it, and it needed an expert to be sent from IBM. What if all of this expertise can be built in together? The second basic tenet is integration by design. Again, a very important concept, because whenever you really look at any combination of the multiple moving parts together, take an example for an automobile. If the best of the breed components are taken together, and if they're not co-optimized, it may not be the best automobile that you're driving. Similarly, when best of the breed components are being brought together to create a system of engagement for you, that may not be the best and optimal solution, because the system is not integrated all the way grounds up, and hence integrated by design. The last but not least is simplified experience. Particularly those who have an experience of installing the middleware, those who have seen how easy or difficult it is to maintain and manage these. I bet you would agree with me. When we look at different administrative consoles, when you look at the different ways in which you can tune your solutions, there are dump readers, there are different expositions, there are manageability interfaces, there are administrative console, there are ways in which you can capture your logs and traces, you can decipher it, you can showcase it, you can have, the different views and outliers. It's just too complex to manage the systems unless there is one single pane of glass, one single way in which you can put all of these experiences together. That is the simplified experience, or a single pane of glass. So if I move on to, with that, introducing the PureSystems with a brief background on what is the genesis of the expert integrated system, we launched 2 systems. One is an infrastructure space, one is an application or the middleware space. The PureFlex, that's the first system that I'll talk about, is called PureFlex because it has the flexibility with which you can configure the system all by yourself. So when I talk about flexibility over here, this system, which is a PureFlex system, by design has a Flex System Manager, which offers you all of the infrastructure availability, monitoring, metering, security features by design, which you don't have to worry about by creating a solution for your infrastructure availability or infrastructure security or any of the modeling, monitoring, metering kind of functionalities. And best of all is we give an option in the flexible system called PureFlex for you to choose your operating system, for your virtualization layer, for your networking components, for your storage. And you can choose any of the compute nodes, which could be either the PAR, which is P7, or Intel based, which could be Intel architecture, which is X architecture as we call it, right? So this is the infrastructure which comes in Express Standard and Enterprise Edition, and it of course comes with the choices that you have, all the way from 8 cores to what you saw in the earlier slide. We can go a little over 608 cores, and you can have flexible storage, networking, what the components that you wish to. However, I'll spend most of the time talking about the Pure application in this session, which is built on the expertise of the foundation of the system infrastructure, which you got to see in the next slide. So the system infrastructure, which is integrated server, storage, which will give the provisioning, security, IT lifecycle management, is all integrated together in the infrastructure as a service piece, on the top of which we provide the application platform through the Pure Application System, which is the first of the launches of the expert integrated system, which gives you that security, scalability, monitoring, lifecycle, the self-service portal, the data management, metering, caching, elasticity, automation, all of it together. So I'll talk about a few of these things rather than just trying to take the names over here. But this is basically to introduce you what we're trying to do. And then the secret sauce which enables us to do this, which is the patterns of expertise. And that's a completely novel concept. So the way we're deploying the IT, the way we maintain the IT, very soon, slowly and surely, is going to change with the introduction of these engineered systems. And what these engineered systems gives is the highest availability by any industry standard. So if you look at the network controllers, storage controllers, any of the compute nodes which you call as ITEs, there is an element of redundancy both at the level of managing of application as well as the hardware. I'll not dwell on this slide, but I'll introduce you a little more concept on the high availability as we go into the next few slides. And it also comes with a pre-entitled patterns of expertise, the virtual application patterns, and I'm going to spend at least about 5 minutes when I really go a little later in talking with the patterns, because that's the secret sauce which enables us to do this, the magic of deploying these things. Right? So imagine a system. What happens today in a traditional IT, and I'm going to compare traditional IT to the world of the deployment when we see the Pure application system. And what is this magic all about, right? And how do we really enable that? And in that context, I'll be talking the patterns of expertise. But these are the patterns which you see, and these are the software element that you see, which comes in the Pure application system, which comes in 2 different form factors. It comes with either the Intel blades or it comes with the Power blade. And either of these systems will have the middleware, which is all embedded in. The middleware which you see over here in this slide, the RHEL, the Red Hat Linux, or the hypervisor that we have, which is VMware ESX, that is the configuration of an Intel-based system. You have a similar configuration which also comes in Power, which comes with AIX and Power VM, obviously, but it has the same patterns. The patterns for the database, patterns for Java, patterns for web applications, which is on different level of the versions of the web application server, which is IBM's app server. And all of these elements come with the system absolutely for free. On to the next slide, on the Pure application system. I haven't still spoken about the magic, so it may not sound too interesting yet, but I'll very soon move to the interesting part and we'll have some interactive discussion at the end as well. So this is a system which is completely ready to go. It's not just be integrated, it's not just be installed, it's not just pre-tuned, it's pre-optimized. And when you talk of a system such as this system comes up and running in less than 4 hours. We're talking of an enterprise class system which has a single PID to order, and when you get this system, it is up and running in just over 4 hours. I recall of my experiences in ordering one of the systems just about 3 years back. I had 4, maybe 5 pages of bill of material, and beyond the bill of material, when the system actually was procured, there are at least few components which are missing, and I had to integrate and commission the system, almost handcraft the entire system up and running, which took nothing less than a week, and you may have similar experiences. And the reason I say this, it takes time, is when I actually went around getting the system up and running, I found that some concepts were missing. So the pre-optimized system such as this needs to have everything which comes in a single entity with single product number, a single shipment box, and it comes up and running in 4 hours, an enterprise class system. After getting it delivered, you just have to plug in a power and it comes up. It's also simplified from a deploy, manage, and optimize perspective. Again, we'll talk a bit more about that. And this is a system which I would argue is probably the only system which truly is built for cloud. It's built to provide you that kind of a provisioning, deprovisioning, elasticity, quality management, scalability, all the way ground up, which allows you to cloud burst across the entire system, and I'll talk a little more about that. Again, integration by design, I'll not spend much of time on this slide, but it basically is trying to tell you that all the way from server, storage, management, your development environment, your entire middleware stack, your deployment of the different applications, it's all integrated together, which again is integrated ground up, a virtualized stack with unified management portal, unified cloud group management, the IP group management. All of these comes inherently into the system with simplified experience or a single pane of glass, which is what you see in the next slide, which again is a very important concept. So let me tell on this. I know for the fact, I mean, those of you who have an experience in deploying the IT solutions, if I take an example of just the Western applications or any app server for that matter, and let's take the database or in a 3T architecture, you have some database, you have some user registry, you'll have an app server, you'll have a JDK underneath or some Java layer underneath. You have too many controls, too many knobs for executing over here. There are about 24 switches that you can do in JDK alone, as I said earlier, right? And there are equivalent amount of controls that you can have at an app server layer. So if you talk just the foundation itself, and if you're really looking at managing, you get too many PMI expositions, you get too many viewers, you can have conversion of that into the XLS, putting that into what we call a storage provisioning manager. You have different health centers, you have dump readers, you have outlier views of the health center. There are just too many of these things. And what we really need is a zero downtime system, easily upgradable system, which gives a single point of support, which gives you one single pane of a glass, which is all integrated to manage everything from silicon to application. And I've skipped all the layers in between. It gives you silicon to application, which has the autonomicity which is built into the system. What I'm going to do from the next slide, and of course, as I said, this is the only system which comes up in less than 4 hours, and there is nothing. So if you look at any of the competition, though I don't want to dwell on this slide, but now that we are actually staring at this, what we did was we put best of our staff together, best of our efforts together in trying to install and commission a similar engineered system which is tuned for your web apps, and we tried to see how long does it take to get there, right? What we found is there is 21 pages of manual, 21 pages of an index and little over 1,000 pages of a manual that you got to go through to gain the expertise before you even start touching the system. And it takes nothing less than a week for you to get the system up and running. And we are talking of trying to deploy over here. So this is the only system by far that we believe which is out there as an engineered system across the globe, across the planet, which is engineered to this extent. And beyond this slide, I'm going to introduce you the system. I will go into the next level of details, which is patterns level. So this system, which is the application built on the Flex, comes in 4 different form factors. And there is a reason why it comes as a pre-engineered configuration, which does not vary the way you could vary in PureFlex, for instance. And the reason we look at it is, imagine a car or an automobile that you're driving today. And what if your car has moving parts which has the, again, best of the breeds, the gearbox and struts and anti-lock braking system and all of it, which is not co-optimized. You're trying to put it together. And there is some centralized control which is managing the entire automobile. And it doesn't know what are the moving parts in the entire system of engagement. There is no way it can be optimally tuned or optimized. So let's talk about a cloud. When we really talk about cloud, there is a notion of hypervising your environment. There is a notion of cloudifying your environment, which most of our clients come and tell us. And what they really mean thereby, and what they end up doing is, for you to cater to the workload of any day, if you're a banking transaction, if you're a net banking user, there is a good possibility that you put up a stack together and you create different LPARs, and you shut down and boot up all of these LPARs based on the way you manually sense the workload expectancy. So on a Christmas day, if you're retail, on the first working day of a month, if you are into net banking, you most probably would have created your own solution, handcrafted it, and then you would create your own LPARs on different compute nodes, which are all networked together in your own infrastructure, and then you're trying to put all of these systems together and manually booting it up and manually shutting it down. So that's a complete manual way of doing it, which cannot be optimally provisioned or deprovisioned. Or put it in this way, you are most probably over-provisioning your systems, and hence you won't be surprised to see that typical data center utilization is roughly about 40%. Now let's go to the next step over here, which is I want to talk about the availability, but let's just start with the utilization. Typically, the development system utilization, if you really see in the entire DevOps in the organization, could be about 10%, could be about 15%, and your test would be again utilized to the extent of 10%. Surprisingly, it may sound, but I tried to run one of the similar experiments over here, wherein I wanted to find out in my app server development team, what's the utilization of all of the systems. And when the report came in, the first thing which glared at me right on the top of the stack is there is one system which was not even 5% utilized. And that system was mine, because that's my laptop, right? And half the time when I'm going to do a presentation such as this, obviously I'm using least of the compute cost and least of the storage and least of everything, and there's no way I can probably utilize it more than 5% or 10%, right? Half the time it's even shut down and I'm traveling. So that's the reality of the world. What if you can get all of these, which is your development, your testing, your staging, your production, all of it together in one single system? There are inherent advantages when you look at this novel way of doing the thing, right? The first is your environment, the development environment, or the entropy. I was struggling to find this word. Your entropy in which you're going to do the development will have a verbatim sync into your production. And when you talk of a test, you will have different slew of the tests that you must be doing in an organization. You will have UT, FVT, SVT, system, regression, performance, governance, how many tests, right? And you have those many environments which are provisioned, and that's where the hardware utilization, the system utilization is certainly down. Yet not the primary reason when you look at the system utilization in any of the ITs is all of these discrete systems, discrete compute blades, which are, which are the chassis or, which are the infrastructure that you have. When it is all connected to the network, it's consuming huge networking bandwidth. And what does it consume network bandwidth is? When there is a clutter, when any of the compute node is talking to any other compute node, when you have any of the backend systems, if you can telco, your OSS, BSS, wireless services, whatever it is, right? Obviously, you need to talk to your entire system of engagement, and it clutters any of the networks that you have. You may have 1, 10 GB, InfiniBand, FCO, what are the network that you have, right? You are cluttering 80% of the network barely between your compute to storage and compute to compute traffic, and that's a reality. We call it kind of a northbound traffic rather than east-west traffic. And if that traffic can be confined into a single entity, that will be a data center in a box by itself, which is what you see in this slide, which is the novel way in which you will integrate your entire infrastructure together. There is another fundamental reason why we look at the entire IT optimization from a utilization perspective, not even peaking beyond 40%. And that reason is, when you look at any of your LPAS, for instance, in a compute node, what you typically might be doing is, you're putting all the eggs in a basket. In a 3-tier, 4-tier web architecture, you're putting your all JVMs, all VMs, and all the applications and middleware all on the same compute node. That compute node could be 8 core, 16 core, 32 core, could be 256 GB RAM, 512 GB RAM, whatever it is. And then you will scale out or you will scale up based on the need of an hour or need of a day or whatever it is. But there is a limit to which you can scale out, which is the confines of the blade. What happens when you need to cloud burst even beyond that? That is where the magic happens. You're going to take that 30 to 50 GB of a hypervised image across the compute nodes, and now you're trying to dispense it. All your SLAs will go for a toss at this point in time. You cannot manage your SLA in that 10 for discrete system, at least at a point at which you're trying to get your images out to a different system. And then you're looking at what is the availability of a system from a utilization perspective. And the utilization cannot be more than 40 to 50 because most of the clients tell us the moment it hits 60%, the system starts crashing down. And again, the reason is the same. First, you created your own stack, and you're trying to boot up your own LPAS and shutting down all by yourself without necessarily knowing the dynamicity and agility with which there is a demand which is required from your IO operations perspective, from a transaction person perspective, or whatever it is, web response time perspective, right? Or which are the ways you measure your SLAs on, right? Now let's talk about the availability in the entire system. The first thing, as I said earlier, if you are really parking all your eggs in a basket, your availability of the system is certainly going to be much lesser because if that compute node fails, everything is gone for a toss. Now you can argue and you can tell me that you have n plus 1 combination and every 3 compute node fails, you have a way to start the 4th compute node. But let's look at the fact that unless you have a golden topology of an image which has a capacity to be dispensed across the entire system of engagement in a seamless manner, adhering to your SLAs, what you're actually doing over here is you're creating your solution all by yourself, which is a complex solution which you self-tune, and if one element of that solution has to change, and why would you get the change? Check out many of the examples. Let's say you have the solution which is super duper, which is running, and tomorrow there is a taxation law which changes, which tells you in the retail business you got to add 0.2% of education assessed. Question is not 0.2%. Question is the business process has changed. Or there is a Basel 3 or Basel 2, or if you're in a credit or banking business, you got to there is a mandatory official proclamation that thou shalt change this from tomorrow or else you're out of business. Are you going to shut down your business, or are you going to go to IT and say, how soon can you give me the solution? You would. And when you go back to IT asking for how long is going to take that solution, I can bet you invariably you'll get an answer that at least a quarter. Because you go back to the drawing board, you start working all together, then you again go through the phase of testing, then you create a solution, stage the solution, and deploy a solution, test it, integrate it, performs, measure it, and all of it. What if you can create this magic, which is what you're staring at as a matter of fact, which is an integrated data center, which gives you compute, storage, and networking all in single box with no single point of failure. What if I can tell you that your entire enterprise IT solution can be created, tested, deployed, monitored, metered, all of it in just about an hour as against a quarter? And what if I tell you that on the top of it you can slap in an SLA and have the system take care of any of the dynamic scalability, any of the SLA management, service SLA is the service attributes, or the quality of service attributes, the QoS that your systems demand. Let's talk about QoS. I think it's a very serious thing, right? The quality of services, you are all aware that when you go into the ATM and you try to withdraw the money or try to do a transaction, if you don't get a response in 15 seconds, your transaction is aborted. It's the same thing in multiple payment gateways, right? For instance, if you don't get a response in certain seconds, I'm not talking minutes, that is an SLA. Thou shalt have to adhere to the SLA for you to be in a business. And when there is a change in a business process, and when there is something which goes probably seemingly wrong to some extent, if your business cannot scale up to it. I recall just about 2 years back, one of the famous banks in India, something slightly went wrong in the business process. There was so much of a panic, I can't name the bank, but there was so much of a panic that people queued in front of the ATMs and tried to withdraw all the money from the bank. Fortunately, this Indian bank survived, is doing great, which is a great example of how you can come back again, have that resiliency to respond to it, but not everybody could be so lucky, right? I'll tell you another example. I happened to go to one of the clients very recently where there was a retina scanning system, which is great. In addition to biometric and in addition to face recognition, there's a retina scan. The trouble was, when I tried to get into the room after I registered myself, it took me 2.5 minutes to get in the room. And what was wrong? It wasn't adhering to the SLA. The SLA must have been 2 seconds. When I happened to meet the CTO there, I couldn't refrain but ask him, Why the heck it takes 2 minutes to open the doors? And the only answer which I got is when the system was deployed, it was 2 seconds. The system did not scale up, right? Now, another instance, another example which I can give is, let's say you created the solution. It's not just about a business process. Tomorrow, if there is a security vulnerability attack, all the way up in a JE environment, JE 5, 6 environment, which is at the Java layer itself, right? There is an OSB which comes out, which is what it's called, the security bullet train. What are you going to do? You will have no option but to adapt to that change, which will give you denial of service or whatever protection, and you'll have to do it as soon as possible. Your time to market over here is 1 day, and if it is not 1 day, somebody is going to exploit, some hacker is going to exploit, and you have serious implications of that, right? So what are we going to do about it, right? You need that kind of a magic, which is having a golden topology, which can be dispensed, provisioned, deprovisioned, managed, controlled all by itself. I dwelled on this slide, I think for the maximum amount of time, so let me introduce what I'm really trying to introduce over here. Now, I'm not going to go into details, but I just wanted to introduce a concept rather than going into details of the hardware over here. This is an integrated system, which is an engineered system or a workload optimized system, whatever you really call it, which to me, simply put, is a data center in a box. On the top, what you see in a yellow is a networking layer, which is top of the rack switch, which gives you 120 GB connectivity which goes outside. There is nearly 300 GB connectivity which comes inside, but let's forget about the numbers over here. You get 1G, 10G going outside, and we are an ardent believer of a fact that from a technology perspective, if you heard about Rocky, for instance, we believe beyond the hype and hoopla of InfiniBand and fiber channel or Ethernet and all of that, we believe that Ethernet as a technology is something which will move to 100 Gbps when you have the right infrastructure in place, rather than 40, but our current system does support 110, 40. And of course, you have the storage, which has got easy tiering, and easy tiering would mean that your data from a spinning disk will move to non-spinning disk called SSDs, solid state devices, all by itself when it is needed. And then what you see is the compute nodes, and then the magic in black and red. And that is a PSM and DSM, which does the entire application manageability, metering, and everything together. Now, why do I say that this system is different? What the heck is different in this? This looks so easy, right? What is different over here is the element which is in black over here and red. The red element is getting you the entire infrastructure availability, and this black element is the one which gives the magic of doing everything. And now I'm going to go more to the software side to tell you what it really does. But before I leave this line, the way we dispense everything is totally different. The PSM element, and imagine a scenario in which you have an entity in your data center which you can seek a golden topology from, which is a pattern of expertise. You can edit that pattern, add anything which you want to, tweak anything which you want to, and give it back to that magical entity called PSM, and let the system manage everything thereafter. There was an ad which I recall, which, way back, probably 10 years back when Hero Honda was probably launched first, there was an ad which was, fill it, shut it, forget it. Basically, they were probably trying to say, though it's not an IBM product, I shouldn't say anything on Hero Honda, but probably they're trying to say, you have so much more mileage in that system, right, that, the two-wheeler or the motorcycle. I would probably draw the same thing over here, the marketing jargon, if I will, though not for marketing, which is just drop any application on top of it and just forget it. Slap an SLA on top of it and just forget it. The system will manage by itself. Because the way we dispense the workload from the storage is every JVM is going to go in a completely different compute node. It's not putting all the eggs in a basket. Our scalability goes across the entire system and not across a single blade. If there is a blade failure, if there is a power distribution unit failure, if there is a compute node failure, if there is a storage failure, the PSM knows, and PSM is an active, where exactly it's been dispensed, and it will redispense it without you trying to take care of it, without any manual intervention. Not only that, the way the PSM is going to function is, let's say you got 30 JVMs, and if one of your JVMs is buggy, what would happen in your application today? In your entire application, in the deployment, if there is something which is not responding properly, your rest of the system is going to get loaded because there is somebody who is spraying the traffic and doing workload management in all of your system of engagement in a data center. And if one of the entities fails, the rest of the entity is going to take the entire load, which may mean that the second entity fails, and then the third, and then the fourth. The way power grids fails, your computer system may crash very soon. The way you can manage it is obviously by doing the heroics, which is you can put somebody by 7/24 metering and management of this entire system, but you don't need it anymore in any workload optimized system, in any managed engineered system. What you can actually do is let the system manage it. So if if there is a buggy JVM, this system will be able to shut it down and redispense that workload all by itself someplace else. Let's talk about SLA for instance, right? When you talk of a service level agreement, what if you have a service level agreement that you're committing to a customer which is on the response time, and you want to have 10-second response time? For you to have 10-second or 5-second response time, you may do your own optimization, scale in and scale out. But leave it to the system. The system will not only be able to dispense your virtual images to scale it out by creating multiple instances across the system, across not just the blade but the whole system, but it will also bring in the different elements all by itself when needed, as much needed for the SLA to be captured. Let me give you a very rudimentary example again. When you drive your cars today, and most of you would be having, one of those cars which has got the safety features like, the anti-lock braking system. How many of us tune that ABS, and how many of us even know when is the ABS going to get activated? It's just part of the system, which is a security feature. And it will be activated when you press on the brake pedal if it needs to be activated. We are talking of the same system, which is an expert system, which will bring in an element when you need it to an extent which is needed to cater to SLA. Now, I'm going to introduce one last concept and we'll go on to the next slide. But let's look at a concept which is for you to create that enterprise solution. When you make your middleware choices, when you make your choices of foundation, when your choices of infrastructure, when you start putting a solution together, and you need to be honest and truthful to yourself, I can bet it takes at least about a week or a month or a quarter for you to really cobble up the entire solution together. And the reason it happens is you need to write your own web services, your adapters, your connectors, your protocol conversion, your marshalling, demarshalling, whatever it is, right? There are multiple things that you need to do, JDBCs, ODBCs, all of these things, different APIs, transformation, routing. All of these things are great to be done once when you're learning, when you're educating yourself, but in a corporate IT, what's the fun in trying to manage in putting 80% of the time just keeping the lights on? Rather than that, if I tell you that a system such as this will create an application builder with which you can create the entire solution and deploy that solution in a matter of an hour, not even a day, in a matter of an hour, that's exactly what is expected of an engineered system, which then gives you these benefits which I'm trying to flash on this slide. I won't dwell too much on this, but there are a few facts and figures which you can see for yourself through the built-in expertise, rather than we trying to go to the client and tell them that you need to enable the dynamic caching, you should have done something, and you can probably, again, do it in this particular way. I'll tell you the fact that one of the telcos, probably it's an 8-year-old story. We work in something called High Performance On-Demand Solution Labs, and we're trying to put one of the telcos, which I won't name on this call, and we're trying to get that entire solutioning together and optimizing the solution. It's not just putting a solution together. At the end of it, you'll have to optimize the solution after it's been put together for that particular usage scenario. That's because the system does not have built-in expertise. And when we do that, am I still audible? Okay, something changed over here. The question came in over here, but I'll address the question a bit later. I just saw the question, but I'll address it a bit later. So when we really saw that, we found there is a room to optimize, and trust me, we did 5% optimization. Now what I'm going to tell you is different. That 5% optimization is not just a multi-million-dollar saving. We're talking of this telecom, which the data center uses a wagon load of a diesel to run the data center just for a day. Imagine the saving that you're going to get with that level of an optimization. And we're talking of an optimization in a system such as this, which will give you 7x workload densities, space saving, multiple ways in which you can manage and have your system uptime, which is close to 98%. The reason I say the system is going to be managed much better is because of our ability to have dynamic partition movement, dynamic VM movements, moving your data to a non-spinning disk for faster operation, having your workload dispensing which can be done across the entire system, not just across a blade, to have more affinity of your storage to the core, having more caches, having co-optimized system of engagement, all of it together giving you those benefits which I just alluded to. So let's, in the last section, I want to talk about the pattern of expertise which I said is the secret sauce. For few people who are more from infrastructure on this side, maybe it's something different, but I bet quite a few of you are also the solution consultants who are aware of the middleware nuances which you will be facing day in, day out. In short, when I talk about the pattern, it is something which is pre-installed, pre-configured, pre-tuned, pre-tested, pre-endorsed, blah, 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 blah. Software lifecycle managed topology, which you can just click and deploy, which then will give you that agility and control and repeatability and everything which you want, right? So let's look into the next slide. What are we really talking, right? The pattern of expertise is, if you really look at the left, your CTO or CXO is going to come and tell you that, you know what, I need something like a safety device in my car, right? And I need to make sure that my car does not skid when it rains. That's all that your CXO wants. Who the heck cares? I really honestly believe that you shouldn't be caring about it. If you do, you got to rethink about it. Who the heck cares and should care today? Maybe you should care 10 years back. Who should care? What is the make of my brake shoes? I don't care. I really don't know even what is the make of my brake shoes. For that matter, when you're driving a Tata Manza, do you really know that there is a Fiat engine there? I don't know whether you know it, but I don't know whether you should care about it even if you know about it, right? You have to believe in that integrated system, that it has best of the breed engine, whether it comes from Fiat or whether it comes from Tata, doesn't matter, right? They made the right choices for you. Similarly, they made the right choices for ABS. So we're talking of who is going to give that scalability. Why does it matter? Leave it to the system of engagement, which is, we're talking of some kind of a 3-tier web architecture on the right, which is what you really need to deploy. So when you have this kind of an architecture diagram, and what you need to deploy, which will have some user registry, a caching server, and databases, what you are really talking is a pattern of expertise. So on the next slide, all that I really talked about is, on the left-hand side, we are kind of looking at the application builder panel, which in a particular topology has a web application, and you just put a scaling policy on top of it. You are not managing scaling here. You're asking the system to manage the scaling. And that scaling, you're trying to tell them, do it with 3 instances, but do it with 5-second response time. And then you're trying to bring in some database. How does it matter whether it is DB2, MySQL, or Oracle database? You only care that there is a transactionality and there is a database, which is some kind of relation database that you're getting in, and there's some user registry. What is actually going to get deployed is on the right-hand side. And that is what the system is going to create. When you give that video kind of a diagram on the left, the system is going to create what you see on the right, which has that ND cluster, which is a vSphere network deployment, which will take care of the application server, provisioning, deprovisioning of that. You'll have something called vSphere Extreme Scale, which will come underneath from a scalability perspective, from your HTTP session persistence perspective, and that will be managed all the way by the system itself. So the next slide shows what the application builder panel is. In this case, you can bring in any element. Though in one of the slides, we talked about what's the software which comes into the system. You can bring in any of the elements, whether it's Oracle database, whether it is open source like Tomcat or JBoss, any of the web application JEE related elements of the components of your solution can be brought in as a virtual image on the left-hand side palette, which can just be dragged and dropped, and the links can be created, and these links are the web scripts which are already there into your palette, and then what you see on the bottom right are the policies, and what you see on the top of this in the middle is add policy for the application. You can add the policy to it, and you can basically just click on a deploy. I can tell you the fact that I can create a complex topology, which is the standard web app topology, using this system and using this concept on the PureApplication system in matter of an hour, which is an enterprise class app in a way, which is very similar to what you might be, I mean, absolutely, I'm sure that you're familiar. Today you can go to Google App Store, you can buy an app, you can just drop it on your system, you can or buy an Android app for 99 cents, and it just functions, right? That's exactly the magic that we're trying to create in an enterprise IT, to create something similar. But while we say we're trying to give you these systems which are, the virtual system or the virtual application, we are also trying to have the controls which are given to you to an extent in the VCS pattern. I won't go in most of the details over here because I'm not too sure what's your level of interest in looking at it. But this is the kind of a level of control that we give in a virtual system. The different kinds of the pattern, which are virtual system and virtual application pattern. Virtual application pattern is as simple as you can get your enterprise application and you can drop it on the top of the system, which within minutes the system will understand and start functioning, which is getting your ER or a WAR file, which is enterprise archive, and drop it to the system. You'll have less controls, less knobs to tune, but the system will take care of everything. So that's in a VR pattern, which not every solution scenario will fit into. And this slide again will talk about what are the benefits. The gist of this last slide is, what are the virtualization that you're doing today? Quite possibly you are doing the LPAS and you believe, possibly, you may not be, but I urge you not to, the application level virtualization is different than overall virtualization. By creating the different LPAS and trying to manually boot it and shut it down, by creating your own instance and your own middleware and your own tuning, and if there is one security patch to be applied, you will go node by node by node across the data center in trying to have that security patch. Imagine if you get a system which will do all of the patch management all by itself. Imagine if you get a system which allows you to do even the version control in your middleware. There are clients who come and tell me to change the version of their app server or the database takes them about 3 months. What if you can have some way of rolling upgrades without shutting down any of your VMs, and the system managing and doing the rolling upgrade to get to the latest of the level in a couple of hours, not in a couple of quarters. When we look at that, that gives you, in addition to the 20 to 25% benefits of the virtualization, that is the one which is going to get you another additional 30 to 40% benefit. Again, this is use case dependent, so we'll not talk about it. It really depends on what is your enterprise IT looking at today and what is the kind of an automation that you built in over there. But we're basically talking about the patterns which will give the scalability, failover, load balancing, security, the entire quality management, and of course the policy management which you see over here, which you can do on this system, which in this particular diagram which you see up over here, you can have a policy which is 5-second response time, but don't go beyond 10 instances and have a trigger in 120 seconds. So all of these things can be managed perfectly by the system by itself without you trying to intervene into that. To an extent, I mean, how does it happen, right? The reason this is going to happen is we on a particular node will be able to add more app servers as needed, which is the dynamic provisioning and deprovisioning in real time. And that's something which is the magic of the patterns expertise. We of course give you the tooling in the application system, and this is the tooling which lets you create the virtual images which may not be already there in the system, but this particular slide shows you that there is a system which is already evolving and has evolved, I would say, which is the patterns of expertise which are coming from different vendors together. There are many which you are already aware of here, maybe the Manhattan Associates or the SAP or Chico CRM. So if you are deploying SAP in your application today, or if you are a telecom customer and if you have a solution from Comviva and DBill, you can at a click deploy this solution without you needing to optimize it, without you needing to tune it, because these patterns of expertise from these vendors are already present on the Pure System Center, on the Pure Application System, which you can just click and deploy. So in my last slide, to wind it all up, and we're going to open for the Q&A. To wind it all up, we're basically looking at the Pure Application being able to address the variety of the workloads across the different periods of the year as per the capacity planning. If you're a bank, you're really scared about, or not scared about, but cared about, on the first working day of any month, how do you cater to that demand? You're looking at the entire system utilization going not marginally up, but going all the way from 30-40% to 70%. You're looking at getting all of your development, test, and provisioning, your staging and deployment environment, operation environment, all of it together with an improved availability, reducing your time to market substantially, magically, all the way from quarter to an hour. And we actually seen that in one of the customers right over here, right in AP, not in India, when we really got the system, we could deploy the entire system and the first application on the very first day. Enterprise class application being put on a system, on a brand new system, which has got all these moving parts on the very first day or in a couple of hours. So that's exactly what we're talking about in this data center in the box, which gives you faster go-to-market, dynamic workload management. And when it comes to license metering, we will be able to license, meter, and manage it on the application system across the cloud groups. And cloud groups is a new concept. Cloud groups is basically a logical partitioning and a logical separation that we give for you to be able to create a development environment which is totally different than your deployment environment or your staging environment. And we give you that service level attributes which can be managed at each of the cloud group and deployment at each of the cloud group. But the license metering to ensure that you don't fall into an audit jail is done across the entire system. So that's what I wanted to share. I'm pretty much done with this. I can check the questions which Mohini, I suppose we are going to put up into the panel over here. So what I'm going to do is I'm going to look at a few of the questions which already came in. And let me read this out. The first question comes from Arpan Ghosh. And Arpan is asking, could you explain what IBM Watson actually is supposed to do? So what IBM Watson is really designed to do is a little different than what a general purpose Pure Application System is designed to do. Watson was designed for a specific purpose, which is an AI system, an intelligent system, which is fast enough, which is quick enough to do something which is unimaginable in the past. So what we could demonstrate with Watson, and where we are really headed from Watson, is what we could demonstrate from a Watson system, which was in something called Jeopardy. We could actually have the real life slangs and knowledge interpretation for us to understand what that question is, and then try to decipher maybe the wit and the humor out of it, and have the real-time data mining, like real-time business event correlation, to arrive at the right answer, which is looking at completely different discrete parameters in a big data environment. When I talk about big data, we're talking of multi-petabyte of a data or zettabyte of a data, which then can be analyzed in real time, looking at those business events which can be processed in real time, and then inferring something out of it. In Pure Application System, it's a general, where Watson is going to head tomorrow, like WebMD, you'll have something which is, if the Watson comes in a form factor of a laptop, today it doesn't obviously, maybe all of you will have a personal health assistant, which will be not only as good as a person that you actually go on a visit for the doctor, but may even be better than that, because it will actually monitor all the vital parameters of the body, which will be your blood rate or heart rate or whatever it is, right? So anyway, that's the first question which I had. So in a way that is different. What we are talking about a Pure Application System is a very general purpose system, which is in your telco or your government or your retail businesses. So I hope Arpana answered your question. If not, you can always write to me. The next one comes from Abhishek. Does it also have an integrated firewall system? So Abhishek, it does have the patterns of expertise, and if you go into the PureSystems Center, which is ibm.com/experts, and you can find the PureSystems Center, you can Google it probably. In the PureSystems Center, you will see there are patterns of expertise for firewall. But let me extend this question. Let me extend this question as, why did you say this is a data center in a box, right? So if you have to answer that, this DC in a box called PureSystems Center, sorry, PureApplication Center, it takes care of the cloud group management, IP group management, VLANs, DMZ, non-DMZ, all by itself. Of course, it has the firewall, and all of it is integrated into the system. You can, of course, integrate it with the rest of the IT which you have in your own enterprise. But then IP group management or VLAN management is all left with the system. You don't need any another C agent, or you may not need another Cisco Nexus or whatever it is, especially if you're looking at this as a data center. Obviously, you'll need it still for the rest of the system that you need to manage in your DR or expense storage or what have you, right? The next question comes from Fateh Ahmed. And the question is, can you please share some of the information related to some of the most demanding IT certifications offered by IBM worldwide? I take this as a question related to the PureSystems. So, Mr. Fateh, there are specific certifications that we have on the PureSystems Center based on who you are. If you are a developer, there is a developer level certification. If you are an independent software vendor, for you to embark on a journey in creating a pattern of expertise, you need to pass and clear yet another certification, because each of the pattern of expertise goes with an IBM endorsement of quality, because we sit with you on each pattern which goes out into the system, which means we are investing in you, which means we're going to qualify you before you even come forward with a proposal. So that's a certification that we do for ISVs as well. If there is any generic question, Mr. Fateh, which is what are the different IT certifications offered by IBM? Every certification which is offered on every product is offered even in India, may it be on Cognos or Chiverly or App Server or collaboration software, what have you. You can, of course, find the information from what is called IBM Developer Works. You can Google it. It's called DW or IBM Developer Works. You can create your own ID. You'll get a plethora of material out of there. Next few questions come from, I don't know in which sequence these questions are coming, but I'm just going to take it in random order. But the next question which I see over here is from Pankaj. Pankaj is asking which type of OS have installed in this cloud computing system. I'll probably rephrase this question. I think the question is, what OS does this PureApplication system have? At an operating system level, on Intel box, it comes with RHEL 6.2. On Power-based system, it comes with AIX. AIX is IBM's own Unix-like operating system. And of course, you are aware of the Linux, which is RHEL or the Red Hat Linux. So these are the two operating systems. The hypervisor is either the VMware ESX or Power VM, and you don't get to change it. This OS across the entire system stays the way it is, because in a way it's like an appliance. In a way, though we say it's an open system, we can bring in any workload. We don't want you to, go back to the automobile. We don't want you to change the gearbox, because we don't know, even if you really get a gearbox out of your Honda and try to put a Beamer gearbox into that, despite the fact that it will be one of the best of the breed gearboxes from BMW, it unfortunately may not fit into Honda, right? So we don't want you to take anything out of this system and don't pluck out anything and don't put in anything. However, the computer upgrade can be done with zero downtime. There is no single use case that we know today which requires the system to be taken down or your application to be taken down. Let me look at the next question from Roy Verghese. Roy is asking, what is the image format for the instances created and whether it is interoperable with public cloud? Terrific question, Mr. Roy. Like this, love it. anytime when we are looking at an innovation such as this, we could change the market dynamics. We could change the way the entire IT is going to get deployed tomorrow. And the reason I say this, Mr. Roy, though it may sound a little funny, you may probably be, mocking me at this point in time. What is this guy trying to tell me? Probably 10 years later, if you and me meet someplace, Roy, I can guarantee you, you will come back and tell me that this is exactly what we talked about, right? Because it's the same thing which happened in 1979. When we had the first IBM PC coming out, people looked at that and said, gee, I mean, who the heck needs this, right? And today the world is totally different. Tomorrow, I can guarantee you, the world is going to be different with PureSystems. And I'm not talking just on the Pure application, but the PureSystems. It's a serious bet which IBM has placed, one of the biggest bets, in the way we deploy, manage, and create IT solutions. To go to your question, in any such transformational innovation, a company such as IBM will obviously embrace the open formats. We are using something called OVF, which is Open Virtual Format, which creates the open virtual archives, which are interoperable with IBM Workload Deploy or IBM Smart Cloud, or any such entity which is a public, private, or hybrid cloud, which understands OVFs. The next question again comes from Mr. Roy, and this question is, how can we manage the scalability related to SLA and PureSystems? Roy, you're asking terrific questions. I love it. We should meet sometime. This is Friday, so we can meet for a drink maybe tonight. How can we manage scalability? Beautiful question. Managing scalability is a fairly complex thing, which it depends on your solution topology itself. And that's where the expertise comes in. That's where the built-in expertise comes in. The built-in web architecture expertise comes in. So when you talk of a scalability, what does it really mean, right? You are going to ask me, it's something which is, you're going to ask me, let's say you have a solution which is a banking application, and you're saying, I need this TPS. That's your scalability definition. What I need is a transactional throughput. You're going to come and tell me that my portal has to respond in these many seconds. That is yet another scalability need, right? Because that's your SLA. And maybe the third guy is going to come and tell me, which is a completely different requirement, which is, I'm going to make it up, but what is it? Well, I can't think of anything which is I'm just blanking out, but there are different scalability needs. Based on that, we need to bring the different products which are already proven to do a specific task, right? Let's talk of another scalability we were talking, which is you're going to do the real-time business event analytics for your fraud management, right? What I mean thereby is, if there are 1,000 CCTV cameras in your enterprise, I'm just making it up, or 10,000 cameras, you want to see what are the events which are happening in real time. You want to analyze those events in real time, and you want to infer whether it's a security threat based on what are that you really gotten together, right? And what you want to say is, what if I have yet another building which gets integrated from tomorrow, and my 10,000 CCTV cameras goes to 50,000, right? That's your scalability need. And you still have to maintain your SLA, which is in 3 seconds of the person entering my secure premises, I need to flag an alarm. I just made it up online. But when you look at that kind of complexity, that kind of event generation, that kind of analytics, that kind of big data, petabyte of tier 1 data, data analytics, right? We are really looking at a system which is capable of doing all of these things, but putting the different things underneath. Now, how does it do it? A, we have a capability to do the dynamic live partition mobility. We have a capability to move your workloads dynamically into the solid-state devices which do the faster throughput. We have a capability to consolidate all the VMs together into a single compute node, into the same memory, into the nearby, into the coexisting entropy of your workload, for you to have better affinity of your storage pages to the CPU, better throughput which is expected of that workload, which is better workload density. And we are also going to bring in different products underneath without you knowing about it. So if you ask me on the application system, you need something like HTTP session persistence. You know what I mean? Let me define this. Let's say you have dispensed different workloads into different nodes. Maybe you're manually doing it today. You have 5 VMs and you dispensed it into 5 different blades. And now what you're really looking at is, what if one of the VMs fails? What you're going to do now is, you're going to redispense it some places. What happens to my session? I was trying to do an e-banking transaction. My session is gone. No, that's not acceptable. So we're going to bring in a different product like Extreme Scale, which will not let your session fail. That is the scalability. So there are different elements which will be brought together, but that's all that we're talking about as expert integrated system, right? So there is no unique answer to it. It depends on what we bring in. There is yet another question which came again from Roy, which is what exactly the difference between virtual system pattern and virtual. Roy, how do we meet? Okay, it's a terrific question again. So when we really talk of the virtual system pattern, the VSys pattern is the one in which you define your custom nodes, your on-demand router, your database instances, your application server instances. You choose a version. You kind of create your own scripts. So to an extent, you're able to choose what is that you're really trying to have, version 7.3.2 with this service refresh, with this fixed pack. And all of that is something which gives you a level of control if you wish to have it. And when you have that, you can very easily plug in or pluck out any of the components of your solution, or you can change a version or what it is, on a patch or whichever way you want, or you can edit an existing pattern and you can redeploy it, or you can extend and capture it back. So the multiple things that is possible at a VSys pattern, obviously it comes with its own demerits. The demerits is it's not necessarily going to be as optimal as a virtual application pattern. So when you deploy a virtual system pattern, obviously you still get the benefits, which are at least about 20% from manageability, scalability, quality, everything, right? Over and above normally virtualized environment. But when you look at virtual application pattern, you won't even know for the application you bring in what is being served underneath. And that's a virtual application pattern. You only bring in your WAR file. You only ask for an app server. You only ask for a database. The system will provision it for you. Forget about knowing the version of the app. You won't even know what is an app server, because we believe you don't need to know. If you need to know, go for virtual system pattern. The reason we believe you don't need to know, I'll give you a classical example. It may sound strange, Mr. Roy, but I'll tell you the fact, right? When you actually go and probably you go to Amazon EC2, for instance, today, right? And you ask for certain compute and certain storage or whatever it is that you ask. Do you even know where is this computer system? Is it in your ground floor or is it in Tanzania? You have no clue. You don't even need to know. Or do you even know on which particular compute system, whether it is Intel based, Spark based, Z based, P based, whatever it is based, on which it is being dispensed, you don't know. You don't even need to know. That's the fact that we're talking about, right? When we're really talking of the virtual application pattern, we basically looking at you. You give me the application, I'll run it, period. End of story, end of discussion. But I'll manage it, I'll scale it. All of the things which I said are going to be the best optimal thing, but if you believe you don't have enough controls on this, because you want to tweak and change something, you should go for virtual system. We can talk in a little more details based on interest, Mr. Ryan. Probably for positive time, I'll probably pause over here. But that's at the outset is the difference between VSys and React. Another one comes from Preetham Goswami. And Preetham is actually, I happen to know one Preetham Goswami who was with me in the past in IBM. So Preetham, the question is, how is the IBM PureApplication System comparing against Oracle's XR range of systems? Second question is there any secure multi-tenancy feature which is inbuilt into the PureApplication System for deploying it in a private cloud environment, hosting various business units of the organization in a secure manner? Let me answer the second question first because that's easier. Is there a secure environment? Answer is 1000% yes. At infrastructure layer, at middleware layer, at application layer, we give various points of security. the entire security from, in case you know, Peter, on the Tivoli security suite, we have the Tivoli security and provisioning as a part of the PSM. If you heard about Westware application suite from IBM, the IBM workload deployed is part of PSM. So when you talk of that manageability node, which in that diagram which was there for the longest time, on the right hand side in the black, it has all of these elements. So rest assured, the system is secure, multi-tenant environment. And obviously, when you talk of multi-tenancy and metering, there can be no cloud environment unless you have the multi-tenancy, metering, provisioning, all of this, you know, the quality management. If you have, you know, any software as a service hosting, if that is an intent, obviously we need to have that. And hence, your next question is, not only can we have the single system in the most secure manner be used for consolidating your development, test, staging, and production, but you can consolidate completely different discrete workloads across the line of businesses into this single system, effectively raising your utilization, reducing your capital expenditure, reducing maintenance expenditure, reducing your backup and all of the mundane tasks that you do, reducing your energy, reducing your footprint and real estate, blah, 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 all of that. I can also assure you and tell you that even the air conditioning needs which you normally need, because of the dynamic air conditioning that we do. The reason I say dynamic air conditioning is today we're talking of not just the CPU and the compute, we're talking of the memory, we're talking of the storage, we're talking of the spinning list, everybody emitting the heat out, right? Everybody is actually creating the heat. We're talking of this system which can create a heat map which will consolidate the workloads for you to confine the heat to those compute nodes where we can actually give better conditioning. Hence your air conditioning will also go down. Your entire electrical consumption will go down, and you are most encouraged to get all of the workloads across the line of businesses and business units into this single system in the most secure, scalable, optimized usage manner. Now let me go to the first question, which is how does it compare with Oracle's XR system? This is a beautiful question. Oracle has probably about 2 years back launched something called Exadata. Maybe that's what you're referring to. And they also launched something called Exalogic, which also you may be referring to. Exadata is purely a database appliance, which will give a faster throughput for your tier 1 database needs. PureApplication is not built as an appliance, which will function only as a database server. PureApplication can be in a retail business, banking business, healthcare system. PureApplication is a generic web app system as against a database system. However, having said that, PureApplication will still function as a tier 2 database system as optimally. Of course, when you say optimally, as you have more of the FPGAs or, you know, different ways, FPGAs are floating, you know, the different ways in which you can have the hardware embedded to run your software a little faster, the way we do it in embedded devices. The different ways and means in which you can make an appliance faster, simply put that way. So if you do that, obviously Exadata will give you 2x, 3x, 4x kind of performance for your transactional database needs. I can argue that we can have a same level of performance that you can get on DB2 PureScale, for instance. Oracle has an RAC, we call it DB2 PureScale. They're all comparable products. You can look at a use case and you can say they're all comparable. At the end of the day, you know, it's a choice that you have. But most of them obviously are similar. Looking at particular entropy, I can tell you, you know, which one is better. I would argue, being an IBMer, having seen DB2 PureScale, that is certainly better, and I can prove it to you that the recovery is much faster in PureScale compared to Oracle RAC. However, I mean, those again as the choices, there are so many choices that you have in ecosystem. But PureApplication System is not Exadata because it's general purpose. Let's come to another thing called Exalogic. Exalogic is yet another system which Oracle has launched. You can put Exalogic and Exadata together along with the management node, and that will be something similar to PureApplication System, but not the PureApplication. The reason I say this is The Exalogic system is basically discrete nodes with no virtualization, as I heard, as I know, I could be wrong, but it does not have any operating system, it does not have any virtualization, and it's a discrete set of 30 blades. What it means is, when you get your OVA or when you get your, there is no OVM either, right, from Oracle over there, but you can put maybe Hyper-Vs or whatever it is, and when you put it all together, you'll have to install it blade by blade by blade because it's not pre-integrated. And there is no component for provisioning and deprovisioning at all on this system, as I know, again I could be wrong. But when there is no provisioning and deprovisioning, when you really look at the dynamic scalability and workload management, having one of the JVMs which is buggy to very distance, you won't have those capabilities unless you have the management entity which can actually look at the entire provisioning, deprovisioning, scalability across the whole system. And if the whole system has to be one integrated system, you certainly need to have that kind of the management ability to do it, which is not there. So you put yet another management entity outside, and you can have these three boxes together, which will not be, which will be more moving parts, and you can say this is something which could be similar to Exalogic, but not which is similar to PureApplication System, but certainly not to PureApplication. Certainly, if you're interested, I can send you more material than this. It certainly is different, is all I can say, and I can certainly prove you that from the benchmarks that we see, not that they are an industry standard benchmark, PureApplication System is scale better. I have two more questions which came in. I understand I have only 3 more minutes left on the call. I'm going to quickly take that. The first one is from Pankaj. Can we use this type of a system in our day-to-day life instead of the hardware machine? Pankaj, I can tell you the fact that this machine will not only save your time to deploy, time to manage, time to optimize, will change the way you look at the IT, will change the way you respond to any of the business needs which you have in the business. I more than encourage you to use it in day-to-day life. And the reason why it is, let's say I have an existing running system which is a retail solution. You are my boss, Mr. Pankaj, and Pankaj comes and tells me that I want to see a guided selling. You know what's a guided selling, right? Pankaj, guided selling is what you do in India, which is you go to a baniya ka dukaan and you say, 100 रुपए में या 500 रुपए में 5 साल की लड़की के लिए क्या होगा, that kind of a thing. I chose Hindi for those who don't understand. Hindi, we give some specific parameters, which is this much money, this is the occasion, which is a birthday, I want to present it to a 5-year-old girl. The guided selling are not done by many of the Indian retailers today. If Pankaj comes to a mall and say, I want to have guided selling, how soon you can show me proof of technology? On PureApplication, I can show it in 2 days. Without PureApplication System, I can do it in 2 quarters. So if I'm looking for my progression, if I'm looking for my better PVC rating, I'll probably use the PureApplication System. I can show it in 2 days. The last question is from Dishant Kamre, and Dishant is asking, does the PureApplication System use traditional RDBMS or NoSQL? If it uses a relational database system with respect to the cloud computational application, does it support NoSQL? The fact, Dishant, is though the PureApplication System comes with DB2 for free, you can bring in any database onto this system. The reason I say you can bring in, recall I talked about something called ICCT tooling in one of the slides which I flashed. With this tooling, you can bring in any database, whether it is MySQL, whether it is MongoDB, whether it is OracleDB, whether it is DB2, and any application server, any enterprise service bus, any of your messaging layer, any of your user registry, any of your SOA solution components, simply put, on PureApplication System. There's also a good possibility that the vendors of these products by themselves will have the optimal patterns of expertise on these products made available on the Pure Systems Center either tomorrow or day after tomorrow. It's not going to be in 2015, but it will be coming in the next quarter or quarter next to that. So you can bring in anything on the system. I realize I'm on the dot of the hour over here. I truly appreciate all of you joining this webinar. I again want to thank Times Group and the TechGeek team for creating this opportunity for me for IBM and putting this all together. If there are further questions to this, I don't know what's the best mechanism, but I encourage you to go to IBM Developer Works, which is one of the interactive ways in which you can interact with us. I think if there is any, so I don't know, Mohini, if there is a way in which we can take some written questions a bit later, but if there is a way, I'll be very happy to get back to you, either on mail or phone or, whichever you want me to. Thank you very much, and have a nice week ahead.
Well, thank you so much, Mr. Amol, for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for the support in making this webinar a success. The recording of the webinar will be available on techgeek.com or on the webinar page itself by tomorrow. Thank you all. Have a great evening.